So yesterday we were looking at Ridgecrest and looking to see where the earthquake was, what the ground underneath looked like. So we had some uh, bedrock down there, and we found out that the crack would have gone all the way from the surface down to the mantle, so that the piece of bedrock could move up and down and back and forth. Today we want to kind of change our scale. So instead of just looking at a small section around Ridgecrest here, we want to look at a larger section. So today we're going to start off with this map right here showing earthquakes. So these red dots are places where earthquakes have happened. And the two questions to start off with: what parts of the United States on this map right here would have relatively few or no fault lines? Now, a fault is that break in bedrock that we saw yesterday. So scientists don't call it a crack or a break. They would call it a fault. So places where we're going to find fault lines are places where we're going to see lines of earthquakes, where we could actually cut the Earth's crust right there. We're not going to find fault lines, like major fault lines, where there's one or two earthquakes. We kind of explained in the class, if we had a piece of paper and we poked it with a pencil, that's what these would be. It's a piece of paper, it would be the flat map here, and we would poke a hole into it, but that wouldn't cut the paper. If we took scissors and cut it, we would have to cut down like a line, it would cut off a piece. So these fault lines would be where there's lines of earthquakes. Where there's no lines, it's just some earthquakes that happen once in a while. Where do we think some of the longer fault lines are? Well, there's going to be some right over here on the right-hand page of this picture, and then quite a few over on the left-hand side here. So kind of going through California, and maybe some through the Rocky Mountains here. It's just kind of hard to tell if there's a line or if it's just a collection of scattered earthquakes. What we want to do today is to scale up. So instead of just looking at Ridgecrest here and making our model like we did yesterday, we want to expand that scale. So instead of just being like 12 miles across here, we're going to start in the Pacific Ocean. We're going to go right through Ridgecrest, right across the middle of our country, into the Atlantic Ocean, and all the way over to this place called the Mid-Atlantic Ridge. And that's a line of undersea mountains right here. So we're going to make the same type of drawing we did yesterday from the side. So I'm just going to kind of walk you through what we're going to look for, and then I will make the model on a piece of paper, and we'll see what happens. So we're going to start with the west coast in the Pacific Ocean. We're going to have Ridgecrest. We're going to have some Rocky Mountains, Great Plains, Mississippi River Basin, Mount Mitchell, the one that we looked at in class, one of the 6 mountains that we're moving. The East Coast in North Carolina, the Atlantic Basin, which is the deep part of the ocean over here, and then the Mid-Atlantic Ridge. Okay, so what I'm going to do is I'm going to switch to our piece of paper. And what we have then, if I start off on the left side, we started off with the ocean. So now the ocean's obviously down into the water. Okay, so this will be my water line here. So there's my water. So that's the Pacific Ocean. And that's not all of it, that's just where it comes into California. We would then come across a little bit into the land. There was the Cascade Mountains that we saw yesterday. Then it was a valley. Here we had our earthquake. We went into some valleys, some other small mountains here. The next thing on our map was the Rocky Mountains, which are much higher. Then we had the Great Plains, which is a very flat area in our country in the middle of it. Mississippi River, which would be a little valley filled with water. It's the river. We would go to Mount Mitchell, which is a mountain that's 16,000 feet for the Rockies, so about 6,000 feet from Mount Mitchell is going to be right about there, so we'll make it about that high. After Mount Mitchell, we go to the East Coast, which means we're going to hit beach and water, so the land's going to go back underneath, which at this point means we have more water. So this is the Atlantic Ocean. at the Atlantic Basin, so it gets deeper. And then someplace out there we have these undersea mountains. Okay. So that's our diagram from the side of what our country would look like. Now looking at yesterday's stuff, we know we have bedrock. So we're going to have bedrock here, bedrock here, bedrock here, and all the high points. We're going to have bedrock underneath all this stuff. And one question is that we had in class is like, what happens underneath the oceans? Is it bedrock or is it magma or what? So we kind of walked ourselves through it. If it was magma, then this ocean water would cool it off and would turn into rock. So that kind of leads you to being that's rock. If there was no rock here and there was no magma, this water would just keep going down into the earth and would just disappear. So we all kind of agreed that underneath the oceans there's also bedrock. So that's on both sides. Then we also got down to the core, not the core, sorry, the mantle. So the mantle is down here again, like yesterday. And above that, we would have that area where it can kind of soft, where the rock can bend. And from our diagram yesterday, we had the earthquake going all the way from the surface, cracking all the way down to the mantle so that we could get some upward movement on this piece here and downward movement on this piece. Yesterday we said, where does this piece of bedrock end? And that's what we're going to try to find out today. Where does this piece end? So that's our model right now of where we are with what we're looking at in this map here. So now what we're going to do is take a look at this blue rectangle here. And we want to do the same thing. We want to look at it from the side. So to do that, so here we have North America in our Seismic Explorer. We're going to let it run for earthquakes. This is going from 1980 to 1990, so just 10 years of earthquakes we're going to take a look at here. So there's 1986, 1987, 88, 89, and 90. We're going to draw a cross section. So we're going to look at part of North America right here. We're going to go from the Pacific Ocean on the left to that ridge crest, or not ridge crest, that was a place, to the Mid-Atlantic Ridge over here. I'm going to click on 3D. It's going to take that and flip it so we can see what's underneath. And what we're looking for is places where there's lines of earthquakes, because we're looking for faults. So I can flip this back and forth. So right now, I see earthquakes like all over the place. From the Pacific Ocean over to the Atlantic, there's earthquakes all over the place. But from here, we need to see a pattern of lines of earthquakes. So one, we have lines of earthquakes in that Mid-Atlantic Ridge, which is the undersea mountains that we drew on the far right of our diagram. We see earthquakes in the middle of our country, right here. But when I go down and look them this way, they're not a line. There's not a line of earthquakes here. It's just one here, one there. It's kind of like we poked a hole in the paper with a pencil. We didn't cut it with scissors like we did over here. So I go back. So we've checked out the right side. There's a line. This is just scattered earthquakes, and we got lots of earthquakes here. Let's see what's going on over in this section. Oh, so we do have a line of earthquakes here again. So you can kind of see through here we've got a line of earthquakes. Now that's through Ridgecrest. So that's the line that we drew on our paper already for the earthquake. So now the only other line of earthquakes is way over here at the Mid-Atlantic Ridge. Okay, so what I'm going to do is go back to our drawing. So we're going to draw another fault right here. It goes right through the middle of these underwater mountains. And that would be our line of earthquakes, which means there is a fault or a break in the rocks of the bedrock. So that means from here all the way over to here is going to be one solid piece of bedrock. because the earthquakes break off, the lines of earthquakes break off where the bedrock is broken. So this is one side of it. All the way over here is another side of that bedrock. Now this doesn't explain why mountains are moving yet, but at least we're starting to get closer. We're starting to find out that the crust of the earth is not one big piece, it's actually pieces that are broken up. Now when you look from one fault to another large fault where the bedrock is broken all the way down, we call this thing a plate. And sometimes you might have heard them called tectonic plates. Okay, so that's what the plate is, this big piece of bedrock where it's broken off on both sides by the faults. But that's just one plate. So now we've looked at a small area. So we go back here, we looked at Ridgecrest. We now looked at all of North America. So we looked at Pacific Ocean a little bit, all of our country, and over to the Atlantic Ocean. So we've changed our scale. We've gone from about 12 miles to about it's about 6,000 miles across maybe, down to, now we want to look at the whole world. So we don't have to get rid of the earthquakes, we just want to be able to see the whole planet here. Okay, so now you can see if we look at the whole Earth, we have lots of lines of earthquakes. So if you can just follow my cursor here, there's one. That's the whole Pacific Ocean. Appears to be on one big plate. There's another plate here. I'm just kind of following the lines around, so I'm like kind of cutting out different parts. There's one, a smaller one here, kind of like around the Bahamas. We've got the Mid-Atlantic Ridge kind of dividing Europe and North America, and then South America and Africa. We've got a whole mess in Asia. Lots of stuff going on in Asia here. So there's probably lots of little pieces broken up in there. Over here we've got one. Africa seems to be on one big plate. Antarctica is one big plate. Here's the top portion of it, but it goes all the way around the world, so it's actually cutting out the whole bottom portion of the Earth as a plate. So I think in class we counted maybe 19 plates that the Earth's crust is broken up into. And so now we're trying to figure out, we know that the Earth's crust is broken up now, but we still don't know why mountains are moving. We have an explanation sort of why mountains can grow. If we go back to here. So if, in this case, this side of the earthquake went up, we could say that this mountain is growing. So that's one explanation why mountains could grow. They're on a plate that's getting pushed up. They could shrink by getting pushed down. So that explains kind of the up and down a little bit. But we don't understand why, like Mount Everest was going 4 centimeters northeast. That doesn't explain sideways motion yet. We've only explained up and down motion. So that'll be the next thing we need to look at is why and how do plates, how can they go side to side? And that's what we'll look at on the next lesson.